Hi, I'm Claire Sim. This is my final math project of finding the arc length. I'm in AP Calculus AB with Mr. Walsh in his period 4 class. I chose this path because I've run it as a loop in my neighborhood before, and it has two straights that are of equal length and then two arcs on the opposite ends, which are also of roughly equal length. Using the Google Maps tool, I found that these straight lengths are 880 feet each, so 2 times 880 is 1,760 feet total, and then the shorter side's taking a very rough estimate without accounting for sort of the curve of the arc and just taking it from a straight edge from one end to the other, measured out to be about 270 feet each. The length from the inner to outer street is in yellow, and it's about 15 feet, and I chose to take the total by doing 2 times the straight sides, which are denoted in green, and then 2 times the parabola length, which are denoted in blue. I later used the yellow to plot points onto a plane and to put the curve on a plane. This is the graph that I used, and essentially what I did was, if we look back at the map here, I made the x-axis the innermost part of Highland Avenue, and then I plotted two coordinates on the x-axis, negative 135, 0 and 135, 0, by splitting the length of the arc in half. And then the middle of that point essentially is the yellow portion, which I measured to be 15 feet, so 0, negative 15. Using these 3 points, I used quadratic regression via Excel, as you can see in the bottom right corner of the slide. I plotted all 3 points that I had, and then I had Excel find the equation of the curve for me. This came out to be f of x equals negative 15 plus 0x plus 8.23 times 10 to the negative 4x squared. The derivative of this, as I found, was 0.001646x. To find the length of the parabola, I use the arc length formula, which is the first picture here, which is the integral from a to b of the square root of 1 plus f prime of x squared dx. And since I needed to find the length from negative 135 to 135, I plugged that in, and then I also plugged f prime of x, which I found in the previous slide, in, and I found L, or the length of the parabola, to be 270.82 approximately. So the length of the arc is approximately 270.82 feet. My final calculations are on the slide. So 2 times 880, which is a straight side, then 2 times 270.82, which is the parabola length that I approximated using the previous slides in this presentation, which came out to be about 2,301.64 feet total, which means that my total path that I've run is 2,301.64 feet, and that was my project. Thank you for watching.